So as you start doing these, in order to solve them, hopefully your mind goes back to some of the things we've seen before. We've seen two different methods for solving quadratics. One of them is to take the square root of both sides of the equation. In this case, though, that's not going to be very helpful. And I know that because I have both an x squared and an x term. So another method we can use is factoring. And yes, you can factor this to solve it. So for instance, that's what your first step would look like, and then use that to get the solutions. All right, and then once we have that factored form, remember what we're saying is, what is going to make each of these sets of parentheses equal 0? Now, of course, these you can probably just look at and know what they are, but if you ever can't, remember you can just set one of those equal to 0 and solve it. And you could do the same thing with the other one if you can't just look at that and know as well. And so in this case, we can see that x equals a -5 and a +3. Second one, much the same idea, except the factoring is going to be a little bit harder on the second one. I know it's going to be harder because notice the 5 that's in front of the x squared, I can't factor it out of every term. I can't divide everything through by 5. And so that means use the guess and check method for factoring that. The one where we use that box as a visualization. Sometimes we call it box method as well. And when using that box to represent your guess and check, remember, first term goes in the first box, last term goes in the last box, and it's these two diagonal ones that need to end up adding up to the -34. All right, now when we do that guess and check, of course, getting the 5x squared, I hope that's fairly straightforward. Really, you can know ahead of time that it's going to end up having to be a 5x and an x. And the nice thing about the 7 as well is we know that's going to be 1 and 7. The only thing we don't know is it going to be 1, 7, or is it going to be more like 7, 1? And it's a matter of try one, multiply it out to see what those two boxes are, and then use that to tell you which one. Now, since it's going to be a -7, you make one of them negative. This is what you should look like for your box when you complete it, if you use the box as a way to visualize it. And so we can use this now to get our factored forms. We read across the top of the box to get one set of parentheses. We read down the side of the box to get the other side of parentheses. Now that we have our factored form, we still have to solve it, remember. Factoring is just a tool to help us to solve it. And so, once again, you might be able to just look at it and know what an answer is, but I'm betting that at least for that first parenthesis, that you'll probably actually need to set it up as its own little equation and solve it. So, what makes it equal 0 there? Well, we subtract the 1, so that gives us 5x equals a -1. Then we divide both sides by 5. X equals a -1/5. Or -0.2 if you prefer the decimal approach. Either way will work here. And of course the other answer must be 7. So there's our solutions for number 2. All right, now number 3 is where things start getting interesting, because in number 3, again, we look to see, can I go ahead and just factor it? And so I always like to start by looking to see, can I factor out that number in front of x squared? But I can't. I can't divide those by 2. Okay, so that means we're having to really guess and check. So box method kind of a thing. But no matter what, we end up not being able to find that it works. I gave you this problem and said factor it, but it's not factorable. And if it's not factorable, how can it be solved then? And it can be solved, and that's what we're learning today. So, we have learned 2 different techniques up to this point in order to solve an equation. There's the one where we square root both sides, and there's the factor. Now we learn the third method. The third method is called the quadratic formula. This now needs to go into your notes. Right, and we're going to be using this problem now as kind of our way of seeing how this quadratic formula gets applied and how it gets used. Now, first thing we want to do is we want to figure out what a, b, and c actually are. Now, when we talk about a, b, and c, remember the general form of a quadratic is y equals ax squared plus bx plus c. We've seen this before, but if you're a little bit rusty on that, make note to yourself so you remember where the a, b, and c come from. And so, if I want to know what the a value is here, notice that's the number that's in front of, that is multiplied by x squared. In this case, that means it's got to be this number right here. The one in front of x squared is negative 2. So a is negative 2. Next step, b. b, you'll notice, is the number that's multiplied by x. So in this case, notice what's multiplied by x. Actually, I'm going to put that box differently. Let's put it around the plus, because you do want to look at the sign that's in front of it. Since it's plus 7, my b value here is 7. And then c. c, notice, is whatever is added on to the end. Now, since this is a plus 5 sitting on the end, that means that my c value is going to be 5. So that's the first thing we do is we figure out what is a, b, and c. Now, once we know what a, b, and c are, that means we now can actually go ahead and plug into the quadratic formula. So let's go ahead and start doing that. And so again, that means I'm plugging it into this thing down here. So it's going to be x equals. Now, negative b means write a negative down and then put in whatever b is. Now, b here is 7. If b was a negative, then you'd write negative parentheses and then your negative number. That way you don't lose track of the negative. If we try to do some of these calculations as we plug it in, we tend to think we've already done something and then we do it again, or we don't do it, or something like that. So it's more reliable this way. Then we write the plus or minus symbol. That plus or minus symbol is always going to be there. Then the square root of b squared. Well, b is 7 again, so it goes 7 squared. As a matter of habit, I put parentheses around the numbers that I'm plugging in. It helps you keep everything straight and keeps you from making a possible sign error later. Minus 4 times a, so negative 2, times c, which is 5. And again, I'm using the parentheses to show what am I actually plugging in. Notice one of the advantages of the parentheses is that whether the number is positive or negative, that's clearly shown. If I left off all the parentheses here, it might look like it was 4 minus 2 instead of 4 times a negative 2. All right, and then that is all over 2a. So I'm going to do 2 parentheses, plug in our a value, which is negative 2. And that's the first setup, the first line of using quadratic formula. Now, since we are just learning quadratic formula, I want to go through and I want to do every little step as clearly as I possibly can. So, next line, I'm going to go x equals, so negative parentheses 7, that's just a negative 7, plus or minus the square root of, I can go ahead and do that 7 squared. Okay, so 7 squared is going to give me 49. Minus, and this is where I'm going to make sure to show every clear little step, I'm going to leave that a minus. And then I'm going to do the multiplication of 4ac and plug it in the parentheses there. Notice I'm leaving it a minus out front. This little tiny detail that you're probably wondering why I'm harping on it, by leaving that a minus now and not messing around with it, you save yourself a lot of potential problems. Probably about half of the errors I see people make doing this, and of course I get to see pretty much all of the errors that people make, are because they mess around with that minus too early. Okay, so now I'm going to multiply the 4ac. That means 4 times negative 2 is negative 8, times 5 is a negative 40. Yes, I'm leaving it as minus negative 40 right now. I'm not combining those yet. Okay, now we do 2 times negative 2, which gives me a negative 4 on the bottom. All right, now we got x equals. Now I'm going to simplify a little bit. Negative 7 plus or minus the square root of, and again, first time through, I'm going to show this one extra little step here that most of you will end up skipping here soon. All I'm doing is changing that minus and negative into a plus. That's the only thing I did there. And then we go x equals negative 7 plus or minus the square root of, now I'm going to go ahead and do that addition, which gives me 89 over negative 4. Now, of these lines, do you have to show absolutely every single one of these? No. Does it help if you show more lines? Yes. It almost always is better to show more than to not show enough. Now, of those, though, which ones could you leave out? This one. Only that one. If you leave off this line, you're going to make a sign error in all likelihood. If you leave off this line, you won't even know what you're calculating. So this is the only one that you can actually possibly leave out. And that's only because we could actually say, well, 49 minus negative 40 gives me 89. We can go ahead and do it with the negatives in there as a way to do it. All right. Now, I have this answer. There are two different ways that we will give solutions to these types of problems. And we'll actually take a look and add that to our notes here in a few moments. But before we do, let's talk about it. This is what we would call exact form. Exact form means break it down and do as much as you can of the math involved. But as soon as you have to do the square root and it gives you a decimal, leave it in terms of that square root. That's exact form because we aren't doing any rounding. Now, of course, if the square root gives you a whole number, do the square root. But if it gives you a whole number, it actually tells you could have factored it. And you wouldn't have had to do all this. Right, now, the other way that we can give our answer is as rounded decimals. And that's actually what we're going to have to do here, because you know in the original instructions up here, it says round to the 100th. When it says to round our answer to something, well, we have to have a decimal in order to be able to round it, right? So now it's calculator time. Have out your calculator, if you don't already. Now, when doing this calculation, there is one danger, and that is to try to put in the entire thing all at once. That's going to lead to problems 90% of the time usually. It can be done, but it requires a very prudent use of parentheses in order to tell your calculator to do it in the proper order. A better way, and this is assuming that you're doing it on a graphing calculator, where you just type it in and it shows it visually, and then you press enter and it does everything you typed in for it. If you're using more of a scientific calculator, I'll talk about that in a moment. So first thing I would want to do on my graphing calculator is I would do negative 7 plus the square root of 89. When you do this, you should be getting a number that's about 2.4 on your calculator. It's a big, long decimal. Now, on your calculator, you would then press divide by negative 4. And the nice part about your calculator is that when on the next line you press divide, it automatically puts in ANS. So it's automatically putting in that last answer that you just found, and it's dividing that by the negative 4. And when you do that, you should be getting an answer that's about negative 0.61. And of course, it's a big long decimal. It goes on forever. Now notice, I did this first one with a plus there. Well, this plus or minus in our formula means you've got to do the calculation once with a plus, and you have to do it once with a minus. So now, I go and I redo the exact same thing, except this time I'm going to do negative 7 minus the square root of 89, get that number, and then divide that by negative 4. Do it on two separate lines. It keeps you from having to mess around with parentheses. And when you do that calculation, so you can check yourself, you should be getting an answer of about 4.1 4.11. Notice I'm giving 2 decimal places because, again, it told us to round to the 100th place. So that means 2 decimal places. Those are the 2 answers you should be able to get out. Now that was all for if you're doing it on graphing calculator, makes your life a little bit easier. If you're doing it on a scientific calculator or an even more basic calculator, then you would actually do -7, and then either the plus or the minus, 89, and then you'd press the square root button, and then you'd press equals. Because on those types of calculators, you enter the number first, so you enter the 89 first, then you press square root to take the square root of it, and then pressing equals after that actually does the addition we had told it to do. And then again you would say divide by -4. Now there's bound to be maybe a few little questions about how do I do it on this particular calculator, and we can work on those as we go through. And so when we get to the end of this problem, we got 2 different answers, -0.61 and 4.11. Those are our 2 solutions. X is approximately equal to each of those 2. Again, rounded to the nearest hundredth. All right, and then I had mentioned that we can give our answer in 2 different forms. You might want to make note of this in your notes, might not, depending on how intuitive that idea is to you. If it says round your answer to the whatever place, that's telling you calculate your answer as a decimal. If it tells you to give your answer in exact form, or it might also say radical form, because it's saying leave it with the square root in there, then just leave the square root in your answer. You don't enter the square root into your calculator unless it's a whole number. And again, remember, if it is a whole number, it tells you you could have factored it in the first place.